Welcome to the deep dive. Okay, so we all deal with digital records constantly, right?
Right. Every day.
Well, think about blockchain as like a super secure digital notebook shared across loads of computers.
Constantly updated.
Exactly. And every new entry, a block, gets linked to the last one permanently. It makes it incredibly hard to mess with later. That's the gist.
That's a great way to put it. And for today's deep dive, you've gathered some really interesting sources. We're looking at reports digging into why blockchain isn't everywhere yet.
The challenges.
Yeah, the adoption hurdles. Plus, how it might underpin, decentralized data storage, a different way to handle our files online.
And guides for actually building this stuff.
Yep, development guides. And also how blockchain ties into data security, things like tokenization.
Okay, perfect.
Yeah.
So our mission today for everyone listening is to sort of cut through the noise. Where does blockchain really stand right now?
In the real world, yeah.
What's actually working? What are the big roadblocks stopping wider use? And crucially, what clever solutions are people coming up with? We want to give you the clear picture, ready to jump in.
Let's do it. So, starting big picture, actual adoption, or maybe the lack of it.
Right.
There's tons of buzz, but one of the main problems is just getting companies, organizations to actually use it. A 2020 survey really flagged this.
That was a key concern then.
It was, and interestingly, Gartner research from 2023, it still showed only like 8% of companies they asked had actually deployed blockchain.
8%, that's surprisingly low given the hype.
It is low. Now, they do predict a huge jump, maybe up to 46% by
Huh.
2025, so optimism's there.
But the current state is still early days for widespread use.
Exactly. It suggests many are still, figuring it out, testing the waters.
Which makes sense. It's complex stuff. And that brings up another issue that seems huge. Finding people who actually know how to work with it. The skills gap.
Oh, absolutely. That same 2020 survey, nearly half the people responding said finding the right talent was a major struggle.
Almost half.
Yeah. And Gartner's recent data backs that up too. This lack of tech expertise. It hits everything, building the products, making them user-friendly.
So it's hard to build and hard to make it easy to use if you don't have the right people.
And finding those people and affording them in such a competitive field, it's a real challenge, a major headache, like you said.
Okay, so you've got adoption issues, skills gaps. What else? Trust seems like a big one mentioned in the sources.
It is, and it's kind of two-sided. First, do users trust the technology itself? Especially, say, public blockchains where you don't know everyone involved.
Right, like the Wild West versus a private club.
Exactly.
Yeah.
That private blockchain model, where participants are known and vetted, tends to feel, well, more trustworthy for many organizations. But then there's also trust between the parties using the network.
So trusting the tech and trusting the other people on it makes sense.
And don't forget the simple matter of money, financial resources.
Ah, yes, the cost. That early survey flagged that too, didn't it?
It did. The upfront investment, the ongoing costs. It's a barrier.
Okay, so money, trust, skills. What about the tech itself fitting in with what companies already use? Interoperability.
That's a huge technical hurdle. Imagine trying to get, like, your brand new Mac software to run perfectly with a 20-year-old Windows system.
Yeah, not always smooth sailing.
It's like that. Integrating blockchain with existing, often older legacy systems is tough. Both the older survey and the newer Gartner research highlighted this compatibility problem.
Like trying to plug a USB-C into a serial port doesn't quite fit.
Precisely. And Gartner also mentioned a couple more things in 2023 that are still causing friction.
Go on.
One was just the time it takes to get blockchain products developed and actually out the door, the speed to market.
Development cycles being long.
Right. And the other big one, lack of regulatory clarity. It's hard to invest heavily and build big things when the rules aren't clear.
Definitely. Building on shifting sands is never ideal, so that covers the main technical and resource challenges. What about the business side?
Well, there's the whole issue of customer education, getting potential users to understand the benefits, overcoming that natural hesitation with anything new and complex.
Convincing people it's worth it.
Exactly. And on the flip side, for vendors trying to sell blockchain solutions, sometimes potential partners are hesitant to jump in.
Partner hesitation. Okay.
And then there's the lack of a strong network effect.
Yeah.
The idea that a service gets better the more people use it. Blockchain isn't quite there yet in many applications, which can slow down adoption too.
Right, it needs critical mass. Okay, that's a pretty comprehensive list of challenges. It sounds daunting, but surely people are working on solutions.
Oh, absolutely. And this is where it gets quite innovative for that skills gap we talked about.
Yeah.
Blockchain as a service, or BaaS, is a major development.
Boss, like saws, but for blockchain.
Pretty much. Think of it like renting the complex blockchain infrastructure, maybe some of the expertise needed. Companies like IBM, AWS, Oracle, they offer these platforms.
So you don't need your own army of blockchain experts.
Exactly. It lowers the barrier to entry quite dramatically for organizations that want to experiment or deploy without massive in-house investment.
That sounds incredibly practical.
Oh.
Okay, what about tackling the adoption and trust issues? If Boss helps with skills, how do you get people comfortable using it?
The sources really stress education.
Yeah.
And, crucially, showing practical uses.
Real-world examples.
Yes. People need to see it solving actual problems, not just theory. Think about supply chains, tracking food from farm to table, or pharmaceuticals, like you mentioned. Knowing something is authentic and hasn't been tampered with, that builds trust fast.
Seeing is believing, basically. Makes the abstract concept real.
Precisely. Tangible benefits overcome skepticism.
Okay, and what about that interoperability problem? Getting different blockchains or legacy systems to talk to each other?
There's a lot of work going into developing cross-chain communication protocols and standardized data formats.
Like universal translators for blockchain.
That's a perfect analogy. Creating common languages and bridges so these different digital islands can actually interact and share information smoothly. It's definitely progressing.
That's encouraging. Now, another thing often mentioned is speed or scalability. Blockchains can sometimes get bogged down with lots of transactions, right? One source mentioned this.
Yeah, scalability is a classic blockchain challenge. How do you handle massive volume quickly?
So what are the fixes?
There are a few main approaches being actively developed. One is called sharding.
Sharding, like breaking glass.
Sort of. It means breaking the main blockchain database into smaller parallel pieces or shards. Each shard processes its own transactions, so the whole network can handle much more overall.
Okay. Divide and conquer. What else?
Then there are off-chain transactions, basically moving some of the transaction processing off the main, slower blockchain onto a secondary system, then settling the results back on the main chain later. It reduces the load.
Takes the pressure off the main network.
Right. And finally, there are layer 2 scaling solutions, things like the Lightning Network for Bitcoin or Plasma for Ethereum. These are like building faster lanes on top of the main blockchain highway.
Express lanes for transactions.
Exactly. They allow for many more transactions much faster without congesting the main network. It's a multi-pronged attack on the scalability problem.
Fascinating. So sharding, off-chain, layer 2, lots happening there. And one source, Nebulas, mentioned community engagement. How does that fit in?
That's really important. Getting feedback from users, developers, everyone involved, it helps make the applications better, more user-friendly, more suited to actual needs.
So listening to the people who use it helps drive adoption.
Absolutely. It fosters a sense of ownership and ensures you're building something people actually want and can use.
Yeah.
It's collaborative improvement.
Okay, let's shift focus slightly. Decentralized data storage. This sounds really interesting. Using blockchain concepts to store our files differently. How does that work?
Yeah, it's a potential alternative to traditional cloud storage, like Dropbox or Google Drive. The idea is, instead of your data sitting on one company's servers,
It's spread out.
exactly, your data gets encrypted, then it's often broken into little pieces, that sharding idea again, and scattered across a whole network of independent computers or nodes.
Okay.
And you, the owner, hold the only key to decrypt and reassemble it. The people providing the storage space can't actually see your data.
Wow. Okay, that sounds way more private. What are the big advantages people talk about?
Well, potential cost savings is one, because it often uses spare storage capacity from lots of different people or providers. But the bigger ones are probably data immutability, making it super hard to change or delete data once stored.
Because it's cryptographically secured and spread out.
Right. Enhanced privacy, obviously. Better security because there's no single honeypot for hackers to attack. And more resilience if some storage nodes go offline, your data is still safe and accessible on others.
No single point of failure. More robust, more private, maybe cheaper. Sounds compelling. Are there actual platforms doing this now?
Oh yeah, several. And they take slightly different approaches. One really unique one is the Safe Network.
Safe Network, what's unique about it?
Interestingly, they actually aim for decentralization without using a traditional blockchain for the core storage network. Their goal is bigger, a whole secure, anonymous alternative web.
No blockchain. Huh.
Yeah, they have their own mechanism. And they use Safe Network tokens for a kind of pay once, store forever model. It's quite ambitious.
Okay, very different. Who else is out there? One's using blockchain.
Definitely. There's SIA. They do use blockchain. They encrypt your files, chop them into 30 pieces, and spread them across their peer-to-peer network.
30 pieces. Okay.
Right.
Redundancy.
Exactly.
Hmm.
And there's storage. They run the tardigrade service too. They're a big competitor to SIA, also using blockchain.
Storage. Right.
They're S3 compatible, which is useful for developers. They break files into bigger chunks, 64 megs, use redundancy, and offer fixed pricing. Good for backups, archives, that sort of thing.
S3 compatible is a big deal for integration.
It is. And one more, Utopia. Their focus is really on privacy, anonymity, online freedom. They use heavy crypto, have their own cryptocurrency.
Use of Krypton and Utopia USD.
Right. But again, their core network for communication and file storage doesn't actually rely on blockchain itself, more on encrypted containers.
So a real mix of approaches. Some using blockchain directly for storage orchestration, others using different decentralized tech or focusing more on the privacy layer.
Exactly. It's a really dynamic space.
Okay, let's zoom back in on blockchain itself. Can we quickly recap the core mechanics? How does it actually work under the hood?
Sure. So at its base, it's that chain of blocks. Each block holds information, like transaction data,
Linked together.
linked sequentially using cryptography. That link makes the chain tamper evident. It's decentralized, remember. No single boss. The ledger, the record book, is copied and spread out.
Distributed ledger.
Right. And adding new blocks requires agreement from many participants on the network. That's the consensus mechanism. Security comes from that cryptography, the hashing.
Hashing. We'll get to that.
And some blockchains, like Ethereum, famously support smart contracts.
Self-executing contracts.
Basically, yeah. Code that runs automatically on the blockchain when certain conditions are met automates agreements.
So decentralization, consensus, crypto security, smart contracts optionally. That's the core package.
That's the essence of it.
And Nebulous, one of our sources, really hammered home transparency and immutability. Why are those two aspects so fundamental?
They're key to the trust model. Transparency often means the ledger is public, or at least visible to all participants on the network. Anyone can potentially verify the transactions.
Builds confidence.
It does. And immutability.
Mm.
That comes from the cryptographic linking. Once a block is validated and added to the chain, changing it would require redoing all the subsequent blocks, which is computationally, virtually impossible on a large network.
So the record becomes permanent and trustworthy? You can't easily rewrite history?
Exactly. It creates a reliable, auditable trail.
Okay, you mentioned hashing. Shardium's article went into this. Can you break that down? What is hashing in this context?
Right. Hashing is absolutely fundamental. It's a cryptographic process. You take some data, any data, a little or a lot, and run it through a mathematical function, a hash algorithm.
Like SHA-256?
SHA-256 is a very common and secure one, yes. The output is a fixed-length string of characters, the hash. Looks random, but it's unique to that specific input data.
A digital fingerprint.
Perfect analogy. And the key thing is, change even one tiny bit of the input data, and the output hash changes completely and unpredictably.
Okay, so how does that secure the chain?
Each block contains the hash of its own data. PLUS, the hash of the previous block.
The link.
That's the chain link. If someone tries to tamper with the data in block 100, its hash will change. But block 101 already recorded the original hash of block 100. They won't match anymore.
And the chain breaks. Digitally speaking, the tampering is obvious.
Instantly obvious to the whole network. That's what provides the integrity and makes it tamper evident.
Very clever. It's that chain of fingerprints that locks everything down. And I saw a mention, I think, on Reddit that you can actually build your own blockchain from scratch.
You can. It's definitely not trivial, requires serious coding skills. But there are guides out there, like one using the Go language.
Oh, Go. Okay.
And there are even libraries, like one called DarkFi, that provide sort of pre-made building blocks to help developers assemble their own custom blockchains.
So the tools are becoming available for those who want to get really hands-on. Fascinating. Okay, let's pivot to maybe the most critical aspect for many applications. Data security and privacy. Tokenization came up a lot. What is that?
Tokenization is a really important security technique. The basic idea is you replace sensitive data, like a credit card number, maybe a health record ID, with a non-sensitive substitute. That substitute is the token.
So like a placeholder.
Exactly. It's a placeholder that on its own is meaningless. It has no value, doesn't reveal the original data. But there's a secure, separate system that holds the map, which token corresponds to which piece of real sensitive data.
And getting back to the real data is hard.
Extremely hard, hopefully practically impossible, without authorized access to that secure mapping system.
Okay, so why do this? What's the main benefit?
Risk reduction, primarily. If your main systems only store or transmit these useless tokens, and that system gets breached, the hackers don't get the valuable stuff.
The crown jewels are elsewhere, protected.
Right. And it can also really help with compliance, like with PCI DSS for payment cards. If sensitive cardholder data isn't stored in a particular system, that system might fall out of scope for some of the strictest PCI requirements, simplifying things.
Ugh, reduces the compliance burden potentially. That's a big deal for businesses. And we saw that PubMed Central Source using it for clinical trials and real-world data. How did
Yeah.
that work?
Yeah, that's a great example of balancing privacy and utility. They can issue tokens representing patients in a trial. Then they can use those tokens to link the trial data to other health records, maybe hospital visits, pharmacy records, without ever exposing the patient's actual identity.
So you can track outcomes long-term, see how treatments work in the real world?
Compare different patient groups, all sorts of valuable research, but without compromising individual privacy because you're only dealing with the tokens in the linked data sets.
That's really powerful. Using tokens to connect data while keeping identities separate. And the PCI Security Standards Council document, that went deep into tokenization for payments. What were the key warnings or guidelines there?
They really stress that while tokenization is great, the security of the tokenization system itself, the thing that holds the map, is absolutely critical.
Makes sense. If that gets breached, you're back to square one.
Exactly. So, strong security controls, constant monitoring, robust authentication for anyone accessing it. They also pointed out that not all tokenization solutions are created equal. Businesses need to really dig into how a specific solution works and make sure it's truly secure.
Due diligence is key. They also mentioned securing communication channels and strong authentication, right? Why those specifically?
Secure channels are vital to stop someone intercepting the tokens, or worse, any communication involving the real data during, say, the token creation or detokenization process.
Right.
And strong authentication ensures only the right people can perform sensitive actions, like actually getting the original data back from a token when needed for legitimate processing.
Got it. Protect the tokens in transit, protect the vault where the map is kept.
And they made it clear, if you outsource tokenization, you need a very clear agreement on who is responsible for which parts of the PCI DSS compliance.
Shared responsibility.
Yep. And critically, any part of the system that handles cardholder data, even if it's just the tokens themselves linked to other cardholder data elements, is still in scope for PCI DSS.
Right. You can't just tokenize and forget about security entirely.
Definitely not. And that piano source highlighted the essential first step, identifying what data is sensitive in the first place. PCI data, PII, PHI, figure out what needs protecting based on the risk.
Know your sensitive data. Okay, lastly, a couple of related data management concepts came out. A data catalog from Informatica and data mapping from a Reddit discussion. How do they fit in?
A data catalog is like an inventory for your data. It tells you what data you have, where it is, what format it's in, maybe its lineage, and importantly, how sensitive it is.
So it helps you find and understand your data, including the sensitive stuff you might want to tokenize or secure on a blockchain.
Precisely. It gives you visibility and control. Data mapping, on the other hand, is about understanding the relationships between data in different systems.
Like connecting fields between an old database and a new blockchain application.
Exactly. If you're integrating blockchain, you need to know how customer ID in your old system relates to participant ID on the blockchain, for example. It's crucial for making sure data flows correctly and maintains its integrity when you connect systems.
So cataloging to know what you have, mapping to know how it connects, both vital for managing data effectively, especially with new tech like blockchain.
Definitely. And as we touched on briefly, layered on top of all this are regulations like GDPR, which have specific rules about handling personal data, even using technologies like blockchain. It adds another layer of necessary diligence.
Compliance is always there. Phew. Okay, that was genuinely a deep dive. Let's try and wrap up the key takeaways.
Sounds good.
So we saw the big challenges. Blockchain adoption isn't universal yet. There's a real skills shortage. Building trust is ongoing. It costs money. And getting it to play nice with existing systems interoperability is tricky.
But on the flip side, we saw real solutions emerging. BOSE is helping bridge the skills gap. Education and showing practical real-world wins are building trust and driving adoption.
Right, and work is actively happening on cross-chain protocols for interoperability, and various techniques like sharding and layer 2s are tackling scalability.
And we explored decentralized storage, a fascinating area, using blockchain ideas for potentially cheaper, more private, more resilient data storage, with diverse players like Safe Network, SIA, Storage, and Utopia trying different things.
And finally, the absolute necessity of strong security, especially tokenization, when dealing with sensitive data on or around blockchains, keeping compliance like PCI DSS and GDPR firmly in mind.
Couldn't have summarized it better.
So the final thought for our listeners, as this tech keeps evolving, as these challenges get addressed piece by piece, what completely new things might emerge? Things we haven't even thought of yet.
Yeah, how might it fundamentally change how we manage data or interact online?
And how will that constant push and pull between decentralization's ideals and the practical need for regulation shape where blockchain goes next? Something to think about. Thanks for joining us for this deep dive.